Welcome to this special maths clinic. I believe this video you'll find this video very useful, and then there are a lot of content that I'll post after this video that will be beneficial to you. So I kindly ask that you click the subscription button. The topic for today is cycle geometry. Cycle geometry. Cycle geometry. Cycle geometry has to do with the math that is related to, or the math that is concerned about the properties of a cycle. So the first thing I want to state is the rules, the cycle theorem, the rules that are guiding cycle geometry. You need to understand the rules that are guiding cycle geometry so that you'll be able to solve any problem under it successfully. So I'll go with the first rule. Rule 1. The rule 1 states that the angle at the center of a cycle is 2 times the angle at the circumference. In diagram, this will be like this. If this is the cycle and this is the center of the cycle, let's call this side O, and let's say a line comes from here down to here to touch the part of the cycle, another one comes from here to touch here. Then observe the way I draw this next line. Let's assume from this point another line came to touch the cycle at this point, and another one came to touch the cycle at this point. It is said that the angle, the rule 1 is saying that the angle that is made at this center, the angle formed at this center is 2 times the angle at the circumference. The angle at this center is 2 times the angle at the circumference. So if this angle is 30 degrees, it means that this angle would be what? 60 degrees. That's what rule 1 is saying. The angle at the center is 2 times the angle at the what? Circumference. So we'll go to rule 2. The rule 2 states that the angle in a semicycle is a right angle. The angle in a semicycle is a right angle. And a right angle is 90 degrees. A right angle is 90 degrees. A semicycle is half of a cycle. A semicycle is half of a cycle. So if you want to draw this rule, it will be like this. You draw a semicycle using a diameter to cut the cycle into 3 equal parts. If this is the center of the cycle, so this is the diameter that cut the cycle into 3 equal parts. One of the parts is known as what? A semicycle. So the angle that is formed in a semicycle, like this, is a right angle. That's what we are being told. It's a right angle. That is 90 what? Degree. That's rule 2. The angle in a semicycle is a right angle. Observe where my line came from. At this part where the diameter is making contact with the circumference is where the 2 lines came from, and they touch this part of the circumference. So any angle in a semicycle is what? The angle that is formed in a semicycle is 90 degrees. So we'll go to rule 3. Rule 3 states that angles in the same segment are equal. Angles in the same segment are equal. So how do I explain this in diagram? Draw a cycle. Observe my diagram, please. If a line comes from this part of the cycle and touch this other part of the cycle, and then it moved from here down to this part, then another one came from this part to touch the same part of the cycle, and move from this part to the same other part of the cycle. Observe the diagram very well. You will see that this angle and this angle are equal. It means that if this angle is 30 degrees, then this angle is also what? 30 degrees. They are angled in the same segment. Observe that the left side of this line touch this part of the cycle is the same place the left side of the line is touching the circumference of the cycle. The same place the right side is touching this part of the cycle is the same place the right side of this line is touching the part of the cycle. So the angles formed between them are said to be what? Equal, because they are term angle in the same what? Segment. So we'll go to rule 4. So the rule 4 says the two opposite angles in a cyclic quadrilateral sums up to 180 degree. The two opposite angles in a cyclic quadrilateral sums up to be 180 degree. A cyclic quadrilateral is a quadrilateral inscribed inside a cycle. Yes. A cyclic quadrilateral is a quadrilateral inscribed inside a cycle. That is a four-sided figure that is inscribed inside a cycle. So to explain this in diagram, if I draw a cycle like this, and then I put a quadrilateral in it like this. If I call here A, I call here B, I call here C, I call here D. What rule 4 is saying is that A plus D is equal to 180 degree, B plus C is equal to 180 degree. That's what rule 4 is saying. So A plus D is 180, that is their opposites. It's 180 degrees. B plus C are opposites. But when you sum them up, it will be 180 degrees. That's what rule 4 is saying. And now let's go to rule 5. The rule 5 states that the angle formed between the tangent and the chord of a cycle is equal to the alternate angle. The angle formed between the tangent and the chord of a cycle is equal to the alternate angle. So if I want to put it in diagram, it will be like this. This is a cycle. A tangent is a line that turns the cycle on one part. This is the tangent. Let's assume that this is the center of the cycle. A chord does not follow through the center of the cycle, so it comes like this. So this is the chord. This angle, there's an angle. This is the angle between the tangent and the chord. Let's assume that another line comes like this and then goes like this. This angle here is equal to this angle. If here is 30 degree, it means here is also what 30 degree. That's what rule 5 is saying. The angle formed between the tangent and the chord of a cycle is equal to the alternate angle. This is the alternate angle. This is the angle formed between the tangent and the what chord. This is the chord, and this is the tangent. This is the alternate angle. This is the alternate angle. So these are the rules. Other supporting rules include other rules I need you to know. You should know that the sum of angle on a straight line is 180 degree. The sum of angle on a straight line is 180 degree. What it means that if I have a straight line like this, and maybe I have a line like this, if here is A degree and here is B degree, it means that A plus B is equal to what? 180 degree. That's what it means. The sum of angle on a straight line is 180. The second rule I want you to know the sum of angles around a point is 360 degree. To explain this in the diagram, if I have a line like this and I have another line crossing it, this is a point. The angles that is formed around the points, if here is A and here is B, and let's say here is what? Here is C and here is D. It is said that A plus B plus C plus D is equal to 360 degree. So these are other rules, supporting rules I want you to know. The sum of angles on a straight line is 180 degree on a straight line, and the sum of angles around a point is 360 degree. So these are the rules guiding the cycle geometry. They are called cycle theorems. So when you know the rules, you'll be able to solve problems on this. So what will follow next is problem solving. I'm about to solve some problems relating to cycle geometry, and one or two of this rule might apply when I'm solving the problem. I might have to use one of this rule or two of this rule or even three. But I want you to know that I will never go outside the rules that I've given to solve the problem. And that is the beauty about the geometry. I'll never go outside the rules I've given to solve the problem. Thank you. Pause.
Great one. Great one.
So you are welcome to the problem solving section of this. So this is the first problem I want to solve, and the above, observe the above diagram. Say in the diagram RQT, that is angle RQT is equal to 131 degree, as you can see. Then angle QTS, where is angle QTS? QTS, that is angle 98 degree, is what? 98 degree. Angle QTS is 98 degree. RQP and PTS are straight line. RQP and what? PTS, they are straight line. They are straight line, as you can see. And the problem is saying find the value of angle QRS. Find the value of angle QRS. So we're looking for QRS, that is this angle here. We're expected to get the value. So how do we get the value now? How do we get the value of angle QRS? If you observe very well, you will note that QRST is a quadrilateral that is inscribed in a cycle. If you observe very well, it's a quadrilateral. QRST is a quadrilateral that is inscribed in a cycle. It's a four-sided figure, a four-sided shape that is inscribed in a cycle. And if you remember one of our rules, it said that the opposite angles in a cyclic quadrilateral, they sum up to 180 degree. If you remember one of our rules. So if I call here X, for example, it means that what? 98 degree plus S degree should be equal to what? 180 degree. That is according to the rule 4. Opposite angle in a cyclic quadrilateral sums up to 180 degree. So from here we can say that X degree is equal to 180 degree minus what? 98 degree, and of course S is equal to what? 82 degree. So it means that this side is 82 degree. This angle is what? 82 degree. So the second question says calculate the value of angle QPT. QPT, that is this angle here. QPT, that is this angle here. We're asked to calculate the value of that angle. So since we know that PQR is a straight line and PTS is a straight line, and we know that the sum of angle on a straight line is 180, it means that this angle here, which is on straight line PQR, and this 131 should add up to what? 180 degree. They should add up to 180 degree because the sum of angles in a triangle is 180 degree. So angle PQT, let's say it is Y degree, which is equal to Y degree, can be gotten how? Y degree plus what? 131 degree is equal to 180 degree. So Y is equal to 180 minus 131. Of course, we got 49 degree. It means that this Y here, which is angle PQT, this angle here is equal to 180 degree. By reason of the sum of angle on a straight line, the sum of angle on a straight line is 180. So Y degree plus 131 should give you 180 because they are on a straight line. Similarly, this angle PTQ, this angle here, let's call it Z degree. This angle here plus this 98 degree should give you 180 what? Degree. It should give you 180 degree. And don't forget we are looking at. We are looking for angle QPT. QPT, that's this angle here. So how do I get my Z? I need to get Z. Z degree is equal to what? Or better still, you said Z degree plus 98 degree is equal to 180 degree. Z is equal to 180 degree minus 98 degree, which is equal to what? 82 degree, which is equal to 82 degree. So we can see that our Z is 82 degree, our Y is what? 49 degree. Our Z is angle PTQ. That angle there is what? 82 degree. By reason of that PTS is a straight line, the sum of angle on a straight line, Z plus 98, should give you what? 180 degree. So now if you observe very well, look for angle QPT. And we already have our Y, this angle here and this angle here, Y and Z. And the sum of the three angles in a triangle, the triangle PQT, triangle PQT. If you observe, the sum of angle of the triangle is always what? 180. So that QPT, angle QPT is equal to 180 minus our Y is what? 49 plus our Z is what? 82. And we'll get what? 180 minus 131. And we'll get what? 49 degree. So it means that this angle here is what? 49 what? Degree. So that's our angle what? QPT. So our Z, our Y is what? 49 degree. Our Z is what? Is 82 degree. And our angle QPT is 49 degree. So the very fact that this angle is 49 degree and this one is 49 degree shows that what? Is an isosceles angle. QPT is an isosceles what? Triangle. Because in an isosceles triangle, the two base angles are equal. Two of the angles are what? Equal in an isosceles triangle. So that is the proof for the third question. The third question shows that triangle PQT is an isosceles triangle. Yes, triangle QPT is an isosceles triangle because the two base angles, it has two equal base what? Angle, 49 degree and 49 degree. When two of the angles are equal, it is an isosceles what? Triangle. So I hope you have understand this problem solving. You can see that I combine the rule 4 with another rule on a straight line. I talk about the angles on a straight line. So those are the rules I use in solving this particular problem. Other problem might require other rules. So let's watch out for the next problem. Pause. So yeah, welcome to problem 2 in our cycle geometry solving problems. So this is the problem we are faced with now. In the diagram, PQRS is a cyclic quadrilateral. Let's say it is said that PQRS is a cyclic quadrilateral. It means that it's a quadrilateral that is describing a cycle. If angle QPS, angle Q, look at QPS, that's this angle here. This angle QPS, the emphasis on the one in the middle. QPS, the emphasis, the angle will be at P, because they say angle QPS. So the emphasis will be on the angle at P. So if angle QP, the emphasis here, S, that is 105, is equal to 105 degree, and angle PRQ, the emphasis will be at R. Angle PRQ is 31 degree. Find C degree and find Y. That's the question. So we'll say solution. You begin to observe the diagram of the cycle very well, and then you begin to see which of the rule is applicable. Because you cannot do anything outside the rules. So from what I can see, I observe this C degree, and I observe that it's in the same segment with this angle at R, which is 31 degree. I observe that they are in the same segment. See, what I'm saying is that C degree is equal to 31 degree. By reason of the rule, angles in the same segment are equal. How do I know that in the same segment? I trace this left side of this angle to this side, this part of the cycle, and I trace the right side from where it's coming from to this part of the cycle. Then I also trace this side, this left side of this side, coming here to that same part of the cycle, and trace the right side of that point coming here to this same part of the cycle. So it shows that this angle form is equal to this. So from my observation, they are equal. So angles to the same segment are equal. That's why 6 degrees is equal to 31 degrees. And then that's for the first one. Then for the second one, they say find y. If I observe carefully again, since PQRS is a cyclic quadrilateral, it means that this angle QPS, that is 105, this angle that is marked 105 degree, that is from here to here, it's marked 105 degree, is and this angle here, QRS, that is this whole angle here, which is equal to 31 plus y degree. When I add this angle to this angle, because they are opposite angles, they should sum up to 180 degree. They should sum up to what? 180 degree. So if here is 105, then I need to get from this whole angle here to be able to know my y. So to get this whole angle here, I'll say 180 degree minus 105 degree, which will give me what? 75 degree. And that is because opposite angles in a cyclic quadrilateral so I got 75 degree. That is, this whole angle here is what? 75 degree. That's what it means. So, and if that angle, this whole angle is 75 degree, it means that therefore 31 degree plus y degree should give me what? 75 what? Degree. Why? Because this angle plus this angle make up the whole angle here. This 31 degree plus y degree, they make up the whole angle here, which is 75 degree. So y is equal to what? 75 degree minus 31 degree. So my y is equal to what? 44 degree. And that's my final answer. So I believe that you have learned some things. I will solve more problems on this and more problems again in the next lesson. Thank you very much for listening. Click the subscription button if you find this video useful. I believe you will find this video useful. More content will be coming in, and then if there's any other problem you have in maths, you can post it in the comment section for me to address them. I will come up with topics about them and treat them very well. Thank you very much.